switched on the power supply and I'm going to measure the output voltage, and as you can see it's 30 volt. So before connecting your circuit to the power supply, it's important that you use this black button to switch off the power supply. As you can see, there's no output voltage. So now you're able to adjust the output voltage to a level that you want. For this exercise we're going to use 9 volts. You can also adjust the maximum current that the power supply can deliver. It's now adjusted to 320 milliamps, and for the exercise we're going to do now, 100 milliamps will do. So I'm going to limit the current to 100 milliamps. Again, the output is still switched off. Okay, we're going to measure the value of the resistor to be sure that we have chosen the right one. So first, select the ohm position of the multimeter, and I have to choose the right input. As you can see, there's an ohm symbol above the input terminal. Now let's connect the resistor to the terminals of the multimeter. Now we can see that the display indicates almost 1000 ohm, 0.994 K, well, that's 1 K. So this one is the right resistor. Next, we're going to measure the LED. The LED has a polarity. It has a cathode and an anode, and we want to know which wire to connect to the positive and which one to connect to the negative power supply. So we have to select this diode symbol indicated in blue over there. That means that we have to press this button, this blue button. One press means a beep through setting. When I press once again, it's in a diode position. So now I'm able to measure the polarity of an LED. So now I connect the red wire to one terminal and the black wire to the other. And I can see no light coming out of the LED. So then it's the wrong connection. Now I turn it, black to the other terminal, red to this one, and it's giving red light. So now I have the right polarity. That means that this wire is the positive terminal, called the anode. And I can also read from the display that the forward voltage is, in this situation, 1.65 volt. Okay, so now I'm going to breadboard the LED circuit. I'm starting with the LED, and I just measured using the multimeter what is the right polarity. So in series with the LED comes a 1K resistor, and the 1K resistor will be connected to the positive power supply. The cathode of the LED will be connected to the minus of the power supply. Okay, let me explain how the connections in the breadboard are made. This long row indicated with the blue line is one connection. Similarly, for the red line, it's another connection. And it's quite common in electronics to use red wires, red lines for the positive power supply. It's also quite common to use a black line for the minus or the ground. So I'm using black wires. I don't have a clue why they have chosen blue lines over here, but it's clearly indicated with minus, so it's not really a reason for confusion. Furthermore, each small row over here is one connection. As you can see, there are numbers on top of it. So, for example, this row indicated with 5 is just one connection. So basically, one pin of the LED is connected via one row in the breadboard to this resistor. That's how it works. I'm going to remove the isolation of the wire. You can have special tools for it, called wire stripper. You can also cut with it. It's a special tool, but you can also use a regular wire cutter. It's just a little more work, but it will do the job. So if I remove the isolation, and now I can connect the copper wires to the terminals of the power supply. Basically 2 ways to do it. One is from a side, and then turn this knob tight, and then the other way is inserting it in the hole that is in the center of the terminal. Be sure to connect the metal part of the wire to the metal part of the terminal. Not like this, but more like this. So both connections are okay now. The circuit is breadboarded, and the only thing I have to do is connect it to the power supply. So the wire that runs to the positive terminal of the power supply, and the black wire that runs to the negative output of the power supply. So now it's ready to do some measurements. Okay, now I'm going to switch on the power supply, and as you can see, the LED is switched on now. Okay, now I'm going to measure the voltage across the resistor. So I connect the terminals of the digital multimeter to the terminals of the resistor to measure the voltage difference across the resistor, like this. The voltage difference across this resistor is just slightly more than 7 volts DC. I'm going to measure the voltage across the LED, like this, terminals across the LED terminals, and then we can measure the voltage across the LED and read the display. The voltage across this LED, well, it's almost 2 volts. Now I'm going to measure the current, then I have to change the input terminals and use another setting of the digital multimeter. Okay. I'm going to measure the current through the circuit now, and I remove the jumper wire, and in the position of that jumper wire I place the ammeter now. So the current is now running through the ammeter, and I can read the value. It's slightly more than 7 milliamps.